Welcome to
Hello.
eCHO episode 157. I am Nico. I am live from Cisco office. I am part of
Amazing.
Cisco now. Cisco office in Manchester in the UK. Uh, Joined by teammate Raphael.
Live from my home office in Switzerland.
Yes. So welcome everybody. Welcome to everyone who's joining us. Let us know who and where you're joining us from. Leave us some feedback in the comments. Um, Today we're going to have a fun session, which we invite you to join us to try a new lab we released on Wednesday, which is the first lab we have around Cilium lab around integration with KubeVirt. Um, yeah, I guess, and I'd love to have the opinion again of anyone watching us, but I've seen a lot of interest in KubeVirt, and I guess in running virtual machine in Kubernetes, especially in the past year or so.
Yeah, and I guess this has to do as well with the fact that there's several things, but people want to like homogenize the systems, right? And now that they have Kubernetes and I think a lot of people are starting to understand that Kubernetes is more than just a content orchestrator, right? It's to generate API. You can do lots of things with it, like projects like Crossplane, for example, can be used to orchestrate cloud resources or pretty much any resource that can be managed with an API using Kubernetes. So it becomes your one central point for automating things, right? And so why not VMs after all, right?
Yeah, although sometimes it's kind of dangerous. I'm always wary of doing things like, are we trying to force solve the problem maybe with the wrong solution because it's Kubernetes, we must do everything with Kubernetes. But I think that I guess it also makes sense, right? As you said, it's now a popular uh, API system, if you like, and with everybody moving to Kubernetes, and with let's face it, as an ex VMware employee, I can say that Broadcom is introducing the Broadcom acquisition introducing some challenges. I heard some stories about renewal bills being really high and all that kind of stuff. So, some people, it's the fact that some people are looking into alternatives. Now, I will never claim that KubeVirt is a direct replacement from VMware. Like, there's 20 years of innovation at VMware. Fantastic platform. So it's not going to be the overnight platform to run virtual machine, but it's an interesting alternative.
Yeah, I don't know as well what are the use cases, and maybe some people in the comments would like to react. What are the use cases for KubeVirt? Is it really like your typical working machine, virtual machine scheduling like you would do with vSphere, or is it more like there's some projects where you're pushing the components into Kubernetes, and some components will do fine in containers, but others still require a virtual machine. And so if you want to put the whole project in Kubernetes and you still need a virtual machine for some components for some reason, is it like maybe a lift and shift solution where you just take the virtual machine and just put it in Kubernetes and there you go, your virtual machine is now part of Kubernetes, problem solved? I don't know. Is that the kind of thing
Yeah.
that we're trying to do here as well?
Yeah, I would love to hear feedback from anyone watching us. Like, what do you feel is the use cases, and is it for replace VMware or move away from OpenStack, or are people using it for migration, or it's just from like almost like a green field and a new private cloud? Again, we'll welcome, we'll highlight some of the comments in a bit.
Well, let's do that. We have Tony saying hi from Sweden. I know Tony actually did the KubeVirt lab this week, and he was pretty excited about it. No, feel free to leave them there. I know you wanted to look into KubeVirt yourself. We have Chetsky, sorry, Sechki saying hi and putting a few comments in terms of VMware and of what to do with KubeVirt using Ubuntu latest as the image. Well, that also works with a container, actually. And Nuno is also joining us. Hi, Nuno. From hi, neighbor. And sending a shameless plug saying on Harvester. I'm not familiar with Harvester, actually. I've heard about it a few times. Do you know what this is, Nico?
No, I wouldn't be able to really describe it.
From what I'm seeing, this is it's a hyperconverged infrastructure solution that is based on KubeVirt and Longhorn. So Longhorn being a project from Rancher. All right, we'll have to. I guess we'll have to get deeper into this another time into Harvester. There's an interesting link here. Okay.
So, and we should also
giving feedback on the lab.
We should also say, like, one of the reasons we wanted to talk about this topic is because Dean, our teammates in at ISO released a blog post about KubeVirt, documented it in a great video as well, great demo, 15-minute demo covering lots of the different use cases. And alongside this, a Cilium lab. It's the first lab which we've created, I would say, which is really showcase like an integration between Cilium and a different project. If you have any ideas around other labs that maybe showcase things like, I don't know, Argo CD with Cilium or Kyverno with Cilium, just can let us know in the comments. Always welcoming new suggestions and ideas. Cilium is never done, deployed by itself. It's often alongside other projects. So yeah, just read the blog post, watch a video, and as mentioned, we've got a new lab which is available on iso.com. We'll publish it on Cilium.io as well.
Yeah, it should be coming soon on Cilium.io.
Yeah. Now, what we thought we would do is, again, go through the lab, but try to kind of enrich it with some live commentary. Again, if you have any questions, want us to dig deeper, we will do that as well. And you can go along and do the labs alongside us. Raphael will go ahead and do the lab, and I will be pestering him with questions. And we'll see if he can pass the final exam. Pressure will be on.
All right. Let's see. The lab is starting. It takes a little bit longer than our usual labs. It takes 3 to 4 minutes because we need to set up the whole infrastructure for this.
So while we wait for this, let's talk about KubeVirt. And it's a CNCF project. It's been out for a few years, actually. I think it's since 2016 that mainly Red Hat were like the main contributors to. And I think it was donated to the CNCF around 2019, I think, if I remember correctly. And it's been in the incubating phase since 2022.
It says incubating since April 2022. Yeah.
So I think we're up to version 1.3, which came out in July, earlier July this year. So it's not, see, I wouldn't say like a direct, clearly lots of people using it. I'm sure people using it for in production, not quite at the kind of graduated stage from a CNCF perspective, but integral part of OpenShift. Is it called Open? Is it KubeVirt or something like this when it's using OpenShift, or maybe just use KubeVirt? But clearly, like a big part of their play. Nuno's just dropping some knowledge as well around around
virtualization in Kubernetes. Right, so virtualization on Kubernetes is leveraging the existing managed components, host, cluster, volumes, networks, etc. But he's saying in the case of KubeVirt, it relies on 2 layers. So this Kubernetes itself for the control plane, essentially, right? Plus KVM, KMU for the virtualization itself. And it's true. We've seen this, and we'll see this in the lab. Essentially, Kubernetes works as a control plane, as a controller to create the templates for the virtual machines, potentially to start the virtual machines and to migrate the virtual machines. But the virtualization itself is done by the underlying system, which is typically KVM. All right, let's see.
Cool.
Still 30 seconds for the start. So what are we going to do? What are we going to cover in this lab? We're going to see what is KubeVirt, how to set up KubeVirt. I think KubeVirt will be set up already, but we'll look around at how it was installed in the cluster. And then we'll do some fun stuff with Cilium, in particular because VMs essentially benefit from CNI, right? So with KubeVirt, the VMs essentially get their network managed by CNI, right? And that's the point, and that's where Cilium comes in, right? And so because we can do this, that means we can do all the fun stuff we do with Cilium most of the time. So typically we'll be playing with gateway API, so putting some layer 7 routing in front of the VM, doing some network security with Cilium network policies, and then we'll look at live migration. If we have more time, maybe we can play with other things. I haven't done all the playing I would like to with KubeVirt, to be honest. I haven't had the time. I'm wondering if typically if encryption would work in Cilium.
It appeared to me that everything was worked. That was kind of surprised me in a way that out of the box, it seemed that all the major Cilium features, as you said, that you just listed, just seemed to work. But yeah, encrypting the traffic between virtual machine or between pod and virtual machine. Maybe we can test this out.
I'm going to zoom a bit so it's readable. There you go. If you're familiar with our labs, you might have noticed this is a new setup. The UI has changed slightly. This is not on our site. This is Instruct. They have a new UI version. It's pretty cool. You can actually move things around. So here, for example, we could do this by default actually, but we can actually move the terminal around to have like 2 terminals like this, so we see both of them instead of having to click on the tab every time. So this is pretty cool. If you're doing the lab at the same time as us, and I think Nuno is very tempted to do the lab at the same time, you'll be able to get a badge at the end. We've decided this was going to be a gold badge. So we've got badges on the labs, and usually the basic labs are either this like green badges for like discovery labs where you just look around. There's bronze badges for the getting started, which just show you like a basic the basic features of a product like Tetragon or Cilium. And then there's feature labs that have silver badges, and this one is more of like an integration of Cilium with another product, so KubeVirt in this case. So it's a little bit more, let's say, a little bit more advanced, and it takes several features, put them together, so it's a gold badge this time. All right, so we installed Cilium in this lab. So we installed it with the Helm chart. Yeah, you can install Cilium with the Helm chart or with the Cilium CLI. In this case, we use the Helm chart. It's installed in the kube system namespace as usual. We're using the latest release version, 1.16.2. We set the IPAM mode to Kubernetes. This is pretty standard in kind. The default is actually cluster pool. I don't think that has an impact in this case here for KubeVirt. We're using kubeproxy replacement, so there won't be a kubeproxy used in the kind cluster. In fact, I think, let me see. Yeah, we have kubeproxy mode set to none in the cluster setup, so there's not actually a kubeproxy that is started. If we look at all the pods here, you can see there's no kubeproxy running. This is generally a recommendation. Now, Cilium is pretty good at replacing kubeproxy, so I would just remove kubeproxy when possible in most clusters, unless you really need it for a feature.
But the kubeproxy replacement in this particular lab is also because we have gateway API,
which requires
yeah.
But then if you're going to replace kubeproxy, you might as well set up your cluster to remove kubeproxy entirely. You can do this in quite a few clusters now. And because we have kubeproxy replacement, we need to pass the service host and the service port so that Cilium knows where to find the Kubernetes API server. And then we enabled L2 announcements. This will be used for gateway API. It's a little bit of a edge use case here, right? Because we have a local cluster, it's a kind cluster, and we want to access the gateway API locally. We're using L2 to get the IP to answer us right from the VM. So it's a bit of a hack in this case, right? Usually in production, you wouldn't need this to use KubeVirt with Cilium. You would typically use maybe some kind of integration with BGP, for example, or with a front L3, L4 load balancer.
Yeah.
This is required for KubeVirt, right?
It is. That's one of the main requirements. Now, how would you actually describe what this does?
Yeah, I think this is like an advanced parameter. I think it's described in the blog post, actually. No? Oops, not this one. Here. So it's this host namespace only. I know for sure that Dean would know. I'm not finding it. Blog here. There. To ensure compatibility with KubeVirt's networking implementation for virtual machine device. Okay, so the socket LB is this component of Cilium that allows to pass traffic directly between containers without going through the network stack when two containers are on the same host. It's like a bypass of TCP/IP, as far as I understand, right? Where the kernel will, so the eBPF code in the kernel would pretty much put the two containers, the two applications to talk to each other directly over a kernel socket. And so in this case, we're saying this should only be for the host namespace, so it won't impact, I guess, containers. So we're still benefiting from the optimization, but only for the host namespace, I guess. I'm guessing KubeVirt might not be happy with this kind of optimization. So this is required, okay. And then we're enabling gateway API support, and we're enabling Hubble relay as well, so we can observe what's happening. Cool. So Cilium is already deployed. So we have Cilium 1.16.2 that is deployed. Yeah, operator is okay. Envoy daemon set is separated now since 1.16. And Hubble relay is ready as well. Cool. Now we can check the status of KubeVirt. Maybe I'll put this down. I don't know. I haven't decided what's easier, actually. Yeah. I like that I can split, but it's taking quite a bit of space. All right, so it's a KubeVirt resource. Okay. Let's see what it looks like. There's quite a few things in there. So we have a kind KubeVirt that deploys a KubeVirt. That's it. Okay. All right. So this is deployed. I guess it's mainly for the status, right? KubeVirt. Describe KubeVirt. Because that gives us statuses, right? I think this is the main reason why this object exists, so that we can check the status of KubeVirt, of the controller.
Mm-hmm.
So it says deployed. So it's deployed. Good. 10 minutes ago. And we can check the deployment. So that will be for the controller itself. So KubeVirt rollout status deployment. So there is, there's several deployments. -n. KubeVirt get deployed. So there's Virt API, Virt controller, and Virt operator. So different components of KubeVirt to control the virtual machines and work as a control plane for the VMs.
Mm-hmm.
Everything's rolled out. Now we're going to deploy a virtual machine. So we're going to create a namespace. So all the virtual machines we create are actually linked to namespaces. This is pretty interesting, I find. At least from the networking side, it means that you'll be able to write like network policies and observe traffic between VMs based on namespaces.
Mm-hmm.
There's several like VM orchestrators that have this kind of logic of projects, right? But can you use projects for the same kind of things that you would do in Kubernetes? I don't know.
What's more interesting is, as we'll see in the network policies, again, because you just use labels and your virtual machine pick up an identity that you can apply your network policies. So you have this, rather consistent experience from networking security between your VMs and your containers. So that's a virtual machine, and that's something I found interesting, again, as a former VMware employee. And I mean, we have so many ways to deploy virtual machine, from like Power CLI or straight in vCenter or so many kind of automation tool and stuff. And this is the newest web, a way to do the same thing but within Kubernetes. And it's like a lot of things are very similar to what I've seen in the past around, specifying the size of your VM and the cores and, your specs, in which network it can be attached and on which image it's going to be running. And you can also obviously run some scripts as the VM initializes.
Yeah, that's pretty interesting. So if we look at this, so the VM is attached to namespace, like we said. This VM is going to be called Nginx VM. So it's going to be running Nginx, I guess. That's the idea.
Yeah.
It is not running. I'm guessing if we put true here, it's gonna start immediately. I think that would be the idea.
Yeah.
And then we have the template for the VM here. So what this is going to create, this is the template specification. And then when we start it, we're going to get a new resource type, right? Which is VM instance, VMI. And so here we're specifying the template for the VMI, right? And so this virtual machine instance is going to have labels attached to it. So size, small, domain, Nginx VM. So we're prefixing with KubeVirt.io. I'm pretty sure this is optional, but it's to distinguish in Kubernetes what are the labels used for VMs and labels used for containers. And then we have the spec of the VMI. So the domain, the type of CPU, number of cores, devices attached to the VM. So we have disk and interfaces. So that would be like a default interface. I guess it's going to behave just like a container. Is that a bridge? Do you know? if that actually creates a bridge interface or a VETH.
I think there was a bridge interface, yeah.
Okay. We're going to see something interesting in there when we start looking at, we start observing the traffic, actually. I noticed something before. The memory resources, networks, volumes, and we have the cloud init configuration, the beautiful, dreaded cloud init configuration. So we're going to set the password to Ubuntu, change password, expire false, and then apt-get update, apt-get install nginx -y, and then this is okay. This is amazing. I don't know what does this do. Do I want to know what this does? Okay, so this is the content of the web page we're going to deploy. So bin bash, generate the secret page, generate VM details. It's just easier to code in base 64 these days, right? You don't want to put this in cloud init. So this will be the content of our HTML page. Secret page, okay, and the host name, locale, okay. And
your camera just had a bit of a...
Sorry. Hello, camera, it's going to come back. I need to check that thing. Let's turn it back on. All right. So we have, we'll have the secret page will be in var 3w's HTML secret.html. So it will be served on /secret.html. And we'll have details.html as well. So we can try both of these pages. And then here we're configuring also the sites available default here for the 404. And then restarting nginx. Amazing. And on top of the virtual machine, we're also going to deploy a service called nginx in the KubeVirt demo namespace. And this service uses the label we set for the VM as a selector. So it pretty much behaves just like a container, right? The idea is the service will serve the traffic based on the VM instead of a container. So in this case, it will be Cilium actually implementing this because we're using kubeproxy replacement.
Yeah. So you've got Virt CTL, which is the KubeVirt binary lets us manage and
so we can actually
start virtual machine.
Start the machine. VM, nginx VM was scheduled to start. And now we can have a look at the resources. So if we look at all the resources in KubeVirt demo, we can see there's a pod, and this pod, this pod that is called KubeVirt demo. Can we see the logs? I haven't had a look at this. Okay, it's initializing. Okay, so first it starts the VM here. And then it will start the Virt launcher. That's interesting. There, everything's running now. So if we look at the logs for this pod, not exactly sure what is the role for this pod. What I find that is interesting is I think when we'll look at the traffic, it looks like the traffic is coming from this pod actually. Let's see if we do. You see, it's got the same IP address as the virtual machine instance.
Right, interesting. So
somehow it looks like either the pod is hosting the network stack, or it just so happens that because it has that both have the same IP address, Hubble will tell us that it comes from the pod, but maybe it doesn't actually originate from the pod. I'm not sure. I don't know the details of this. So we have the service here. Probably we could see the endpoints, and we see the endpoint is the virtual machine itself. We've got lots of comments coming. I don't know if you want to put some and discuss them. And we've got the virtual machine instance. Right. Okay. So the VM is started now, and we can actually access it. So there's a schema here. The problem with this schema. I have to see. Yeah, here. All right. So what do we have here? We have the node in black here, and then we have CNI 0 that is set up by the CNI with a vth pair between the vth on the node and the ETH0 in the compute container. And you see, yeah, that's how it is. With the compute container, there's a bridge, and that bridge provides an IP address for the virtual machine. So I think this is the thing that we saw before. This
yeah, it was the launcher.
This Virt container thing. The Virt launcher is actually a pod. This is the link with CNI, right? So this is the pod that will get the network configuration, and then it will set up a bridge for the virtual machine. Looks interesting. Wonder how this will work with Netkit, actually. Will this still work with Netkit? Well, we should try this next time.
Yeah. So there, I think that was Kseski was highlighting is we've put on the side of the some instructions on the in the lab on the right hand side. So
yes.
again, that's more information for people if they as it takes their time going through the lab. There are some explanations about how it all fits together.
What's interesting here as well is that, I don't know, the bridge is getting an IP address via DHCP. That's super interesting. So there's a fake DHCP 7. When the machine starts up, it sends a DHCP request, and it's this container that actually replies with the IP address provided by CNI. It's interesting. It's like literally a bridge between the old and new worlds.
Yeah. But it's funny. Just I like this comment because you think about it, like you could have so many layers of virtualization. It's like Inception, like you create you get your bare metal and you have your VM, and then you build a cluster on top of your VM, and inside your VM, inside your cluster, you can create some virtual machine, and inside that virtual machine, you create another cluster. It's just like you can't really go on forever, but it's it's really just fun how many layers.
In the end, it's packets all the way down.
Yeah.
All right, so let's connect to the virtual machine. We're going to use this terminal here. So we can use Virt control for this, and that will give us an access to the VM. Good old access. I don't remember last time I accessed a machine this way. And yeah, I connected early in the previous attempts for this lab, and I had like the whole booting logs, like I was connecting to a KVM. Don't see this very often anymore. Yeah, so we're on the VM. Cool. Yeah. And oh, interesting. Look at that. I hadn't noticed this.
Yeah.
So I thought the DHCP would give it the IP address of the container, but that's not what's happening. Because here the IP address of the VM is actually 10.244.192, but here we have 10.0.022. So I'm guessing the traffic is actually netted from the VM. It's actually netted through this pod, and we're going to see the traffic coming out of this pod. This is why we're going to see this. Okay, so we have access to the VM. We can see what's running on there. There should be Nginx running, right? Yeah. Yeah, we have Nginx running. we can do a curl locally, right? Yeah, it works. So we have the service running locally on the machine. Pretty cool. Now let's use Hubble. And if we look at Hubble here, what do we have? We have the communication. And that's what I find interesting here. Yeah, we're seeing the traffic coming from the Virt launcher Nginx VM to core DNS. So that's typically when, let's do this. If we have -f, if we follow here and we do a host Google, yeah. So it actually makes a request to core DNS. Pretty interesting. But it comes from the Virt launcher Nginx. So what this also means, because it's forwarded through this pod, it also means that if we apply a CNP to have a DNS proxy in Cilium for traffic, to capture DNS traffic, it would also work, right? Because it would be considered from the point of view of this Virt launcher Nginx. Now, yeah, one thing that is interesting here as well, I think, is obviously, I think these should have the same labels, right? Yeah, so the KubeVirt DOM and Nginx, for example, is the same label, and the KubeVirt IO size small. So it means that all the labels we might use to filter on the VM will actually apply to this pod as well, which is why CNPs will actually work, because they will apply to the pod where the traffic is coming from.
Mm-hmm.
All right. And then we're starting a netshoot container. Netshoot is this very basic container that has lots of tooling for it to do fun stuff with the network. And we can access the VM. It works fine using the service name here. So we're going through the Kubernetes service. Cool. All good.
All right. So we got a container accessing a virtual machine within the same cluster. Are they in different nodes or?
Oh, that's a good question. I wouldn't think so. Can worker. So this one, you mean the pod accessing the VM?
Yeah,
so
the pod is
from
in,
was is on worker 2, and the Virt launcher is on worker 1, and the VM itself is on worker 1. I'm guessing there must be a link, right? I mean, the VM and the Virt launcher must be on the same node because they're setting up the bridge and everything. So there must be some kind of affinity to make sure they're on the same node.
And it's pretty cool, right? We've already got container talking to a VM over VXLAN. Because I think we are.
It's just a couple of YAMLs.
Yeah.
All right.
Right.
And one of the favorite topics of the moment, Gateway API.
Yeah, so you've showed how we can access the multiple different web page on the virtual machine from a pod inside the cluster, and now you're going to access that virtual machine from outside the cluster.
Yes. In fact, I'm thinking we did it from a container. But we don't have an external IP at this point for the service. We could also put an external IP here and use the L2 announcements to access from the VM. That would work as well. But at this point, what we have is we have a Cilium envoy here. But we have nothing with an external IP at this point. So we've activated gateway API. We have enable gateway API true. So that's good. And now we can create gateway API resources. So we're going to create a gateway in the KubeVirt demo namespace. So this will be a dedicated gateway for this namespace. Listening on port 80 and accepting only routes from the same namespace. And then we're going to create an HTTP route that will be attached to this gateway. And it will redirect traffic coming on / anything, actually. It's a prefix,
Yeah.
to the engine service port 80. So let's do this. All right. So now, because we have a service, Cilium gateway that was created, and it has an external IP. And that's because we actually deployed some load balancer IP pool, right? Yeah. I wonder if there's some. Okay. Yeah, it's so what do we have here? Yeah, this is the CIDR that will be used, and there's no specification, right? So it will apply to any service. So we're taking from this 172.18.255.200, which is why we're getting 172.18.255.200, right? We have one IP address and we gave it to the service. So that's how it works. Otherwise, you would need a controller to give an IP address. Okay, and now because we have L2 announcements, we can actually access this from the VM. Okay, let's try it. Ooh, there you go. So here we're accessing the VM, and this goes, how does this go? We're going from the VM, we're accessing this IP address. When we access this IP address, because we're running kind on the local VM, it does an ARP request, and then one of the kind node replies to route the traffic this way. So we access one of the kind node, and then it gets sent to the service for the gateway that is here, because it's this IP address. And then this service for the gateway sends it to Envoy, and then Envoy does the traffic routing to the Virt launcher pod that sends it through a NAT to the VM. And there we go.
Yeah.
All right. And we're able to actually get what we want. Yeah.
Yeah. Just good luck.
Good luck with troubleshooting. Well, it's simple, right? It's very simple. Yeah. All right, it works. It works pretty well. Okay. And so, next we're gonna look at
Yeah, and I mean what's in the lab in this lab. So I guess the premise was, look, we were able to access the Nginx web, the default kind of page, and the /details page, and also the secret page. So what we show afterwards is using network policies to refine this. Now we could also have specified in the gateway route configuration. We could have just done a / instead of doing a path prefix match, which matches any kind of traffic, send it to the the web server. We could have been more specific about which path we are matching and where we send it to. But because the gateway configuration was pretty broad, all the traffic will be sent through to the web server. And another way then to filter is to use network policy at the layer 7. So you say only traffic to the slash details is allowed, and so that when we try to access a secret page later, it will be blocked. But that's kind of part of the next task.
Yeah, I'm thinking of something here. Maybe I'd want to see if we can see the traffic with Hubble UI. Missing some things. That should work, right? Yes. Yeah, we have the Hubble UI running. I'm just going to expose it. What do we have? Oh, yeah, we have 31235 that is exposed. Cube system, edit SVC Hubble UI. And we're going to make this a type node port. No, it doesn't go here. No, it's here. There. Right, and then I should be able to, let me see. Look here. Just a minute. I'll just be right there.
So what you've been doing is essentially enabling Hubble UI
Yes.
on your Cilium deployment.
Yes.
Exposing a port, and in the background you are changing the lab interface for us to be able
and I'm
to
doing
access.
some magic. There we go. So I can use in nstruct, I can actually access the port by using this URL here. So here we have KubeVirt demo, and we can actually see the world accessing the KubeVirt demo. That's interesting. We see KubeVirt demo. I'm not actually sure what this is. Maybe we should have more specific labels, right? Because here, oh, that's the one we ran before, right? When we did this run here, because we didn't have labels, it doesn't know how to name it in Hubble UI. That's why it looks like this. If we used another, yeah, we can put labels, right? Name equals net client, something like this. KubeVirt demo delete for spot TMP shell. If you run it again, and what was it? We did a curl engines details, right? Let's see here, and now we see net client. That's a bit better. We might want to rename this in the lab. That may be a little bit clearer. Yeah. And also, what's nice is because we're using Gateway API, so layer 7, we actually see the layer 7 details in Hubble.
Yeah, but we can't see the launcher like this. The launcher is transparent in the Hubble.
Yeah. Well, or maybe we are seeing the launcher. Are we seeing the launcher, or are we seeing the VM here? I'm not too sure. We can actually see this. I think the launcher may have slightly different labels. Created by. See, the created by is on the launcher, right? So here, this is the launcher we're seeing. We're not seeing the VM. Actually, we don't see the VM. So in Hubble UI, we think we're seeing the VM, but we're actually seeing the launcher pod in there. Yeah, so interesting. And then we see the ingress, so that's traffic coming from the outside, coming from our VM, the real VM.
Yeah. So just to summarize what we've done like in this task before we do the network policy, and we've already been going for 50 minutes. So we've been able to expose our VM running on Kubernetes and managed by KubeVirt. We've been able to expose this to the outside world using gateway API, again replacing our ingress. And we've made it accessible by using the Cilium layer 2 announcement feature, which is like a method LB, if you're familiar with it, which assigns an IP to our external service and also replies to ARPs for the specific IP address. And now you are...
I'm keeping this on the side. I want to see what it would look like when I use DNS.
DNS policy.
So,
right. We're going to go and install a network policy.
Yeah.
So can we secure VM? Can we secure VM the same way we would secure a pod using Cilium network policy?
So let's start with this one. We have a Cilium network policy here, and it's a layer 4 policy. It will apply to the VM here. It will allow ingress from anything matching app equals client. It could be a pod or it could be a VM. Actually, because we know now that VMs are actually just pods. They're actually, the network is managed by a pod anyway. 2 ports, 80 TCP. From entity ingress, that's to allow traffic coming from us, from the outside. So egress is what is used for ingress and gateway API. It's the special identity linked to Envoy north-south traffic. And 2 ports, 80 TCP. So let's apply this. And then in terminal 2, we have, oh yeah, I broke this.
Yeah.
Let's see. It's SVC Hubble relay. Node port. There. I broke it because I updated the stack. Okay.
So in terminal 2, we're running a Hubble observer like in the background, which is looking for traffic to our it's actually to the Virt launcher pod, right?
Yes. Yeah, or to the VM or to the Virt launcher, actually, yeah. So here we're seeing ingress allowed. And that's because now we have a network policy. Which means we could also use like what we do in the Zero Trust lab as well to just inspect traffic coming to and from the VM and adjust network policies. That could be fun. And now we make a request here, and this is actually dropped because it's not allowed anymore to use the temp shell to access Nginx. We can actually see in the UI, actually, now that we have the UI. We should be able to see this. Let's see. So we have some red here coming from the net should count client, I guess. There. Too many filters. Can we see something here? It's not very simple. Interesting. Yeah, we have the red here. And we should be able to filter on drop traffic. So this is the drop traffic here. I don't know why it doesn't come out red. It's weird. Yeah. But at least we can see that the netshoot client hasn't been able to reach the KubeVirt demo VM. Interesting. All right. So we did this. Oh, I doing? Oh yeah, I need to.
Label
I forgot to label the pod. So if I label the pod with app equals client, then it's gonna match the condition, and so now it's allowed. And we can actually see in the UI, we should see any verdict. We should see that it's now allowed. Yep, it's forwarded now. Cool. What else do we have? Yeah, for the secret, it might be problematic. We don't want to get access to secret. So we're going to give access to details via a layer 7 network policy instead. And that will restrict access to secret. Now, this is a standard Cilium network policy. So now we can still, so we cannot access secret anymore. And now instead of being dropped, we get a 403 forbidden. Great. And we see the dropped here. Yeah. So it's an HTTP drop this time. And we can still access details. This is fine. Cool. And again, we should be able to see this in the UI. There's quite a few things happening in there, but we can see that secret now is in dash red.
Cool. Let's do the migration. And that's, I mean, that's was always the wow factor was when at VMware was to showcasing the live migration from a VM from a node to node. I've done some demos where I was doing a live migration across continents, stretching a network, which is not the best practice. Don't do it in prod, but being able to stretch a layer 2 across like different clouds and environment, and then move a VM with a very little impact. So, and this is kind of what this demo is about, but not quite as just within the same cluster. So again, we're using going to be using virtctl to migrate a VM.
Yeah. So for now, the VMI is on the kind worker node name. And we have a loop here that's constantly requesting access to the service running on the VM to make sure there's no disruption. So we're going to migrate it. We can actually do it by posting a YAML. I'm not sure this is not a huge fan of this actually. I don't know. I think it's not very it doesn't. I don't know how this goes with promise theory. All right. Well, it's still on kind worker. Is it migrating or what? Let's check the migration status. It's scheduling. It's scheduling the migration. Let's split here so we can see what's happening on both. Yeah, scheduled, running. So it's running the migration now. Ooh, we got a 503. Okay, we got one 503. I guess that's acceptable. Now we can check the. Now it's on kind worker 2. So the VM was migrated from one node to the other. I mean, okay, arguably this is on the same VM. It's on the same machine, right? Same kernel, because we're using kind. So yeah, it's probably also maybe faster because it's on the same machine. Just moving the machine from one node to the same. It's fast.
And the network policy, we've migrated the VM from a different node. Network policy should still work.
Yeah, it's still
remote access. Yeah. Remote access should still work as well.
Reason. Right? Yeah, we still get a 403. Yeah. It's based on labels, so yeah.
Yeah, and as well the access over gateway API.
Oh yeah, the gateway API. Obviously, I don't have the gateway. All right. There we go. So secret doesn't work because I'm guessing we get a 503, 403. Yep. And details works. Yep. So all good.
That's good.
Works the same. Shall we do the exam while we're at it?
All right.
I already got the badge. All right, so we need to use the editor here to create a virtual machine and a network policy. So the VM must be called exam VM. So we're going to put this here, exam VM, and the exam namespace. The domain will be exam VM. So it says in the instructions here. So this should be good for the VM itself, right? Let's start with this. Not this one. Exam virtual machine. Oh yeah, I need to create NS exam. Ooh, this is tricky. Then we start the VM, virt control start -m exam exam VM. There we go. And then we need a network policy. So the network policy, this is where it gets tricky, right? This network policy should allow the exam VM to access the Nginx VM in the KubeVirt demo namespace. But it's an ingress policy. So that means we need to deploy it in the KubeVirt demo namespace. And it must be named exam network policy. And so this will be from the point of view of the Nginx VM. So it needs to apply to the Nginx VM. Mm-hmm. And it needs to allow access from the exam VM that is in the exam namespace. So again, here we have the benefit of the full expressivity of network policies in Kubernetes to decide that they're allowed to talk between namespaces. And we need to allow access to /details. There we go. Well, let's check maybe before we apply it, if it works. I'm going to create a new no, it's 1.3. Never remembered the port. It's this one. There we go. I'm going to use another terminal because I don't want to. So the console on the exam VM, right? In the exam namespace. Okay. Oh yeah, because it's not Nginx, right? It's it's Nginx dot.
Yeah, it's a different namespace, right?
Yeah, so it's Nginx dot KubeVirt demo. Okay, and that doesn't work. Why doesn't this work? Well, you can see here what's happening. It doesn't work because it's naming, that's a bit yeah, the naming should be fixed for this, I guess, from exam here.
Because we've already
got doesn't work because we have a network policy in place. So the traffic is being dropped, right? So Hubble observe -n KubeVirt demo. And you see we've got traffic coming from the Virt launcher in exam, which is our exam VM, and it's denied. So that's why we need the new policy. And this new policy will actually allow traffic to get to /details for a new VM. Now it should work. Let's try it. Woo, nice. It works.
So that's VM to VM, right? So we've done pod to VM. We've done from outside the network, outside the cluster to the VM. And now we've done VM to VM.
Yeah, between two namespaces even.
Yeah.
Okay, so this seems to work. Last, we need to migrate the exam VM between nodes. So virt control migrate -m exam VM. All right, that should be fine. Let's check. And that's it.
Well done.
Yay, I get my badge. All right.
Amazing. Well, thank you everyone for joining. I know we always tend to go a bit long, but I think we've explored lots of different use cases around applying Cilium to virtual machine managed by KubeVirt, done networking, pure connectivity between, again, pod to VM, outside the cluster to VM, VM to VM, the network security, we've done observability, we've done migration, and pretty impressive.
Yeah, like I said, we could add quite a few things in there. External IP addresses, encryption, Grafana dashboards. You could spend a day on these VMs.
Yeah, 100%. Cool. Thank you everyone for joining us, and yeah, hope you enjoyed the session. If you have any feedback, just again drop us a message on social media, and come and check out our lab on isurveillance.com. And thanks for all the comments and interactions as well. Appreciate that. Fantastic. Have a great rest of the day, everyone.
And is there an episode next week?
No, because I think we are all out next week. So I think it's in 2 weeks.
There's no episode next week. So
yeah,
see you guys in 2 weeks.
For the next. All right. Catch you later.
Take care. Bye.